Hello and welcome you all in the course of probability and statistics. Today we should learn about the skewness. Skewness is one of the component of movements. We know that movement describes the four quantity, and now out of this four quantity, one of the quantity is a skewness. Now, so in this lecture we have to study in detail what is skewness, what are the types of skewness, and how it is useful in our day-to-day life. So let's see the first of all, what is the definition of skewness. So skewness is nothing but is just a measure of the symmetry or asymmetry of the distribution of the data which is given. Suppose we have to check the statistics of any of the distribution just like the data. So data of 100 student is given, data of any of the industry organization is given. Suppose it contains a 500 employee, then the data is given. Then we have to identify the nature about that distributions. So in general, skewness is nothing, it's just study the data is symmetric or not symmetric. Now basically the skewness is divided into three parts, three categories. The first category is known as the no skewness. The second category is known as the positive skewness, is known as say positive skew. And the third category is known as the negative skew, negative skewness. So once again I recall you, skewness is nothing, it just study the behavior of the data. The data is distributed well, that is distributed symmetrically or not. Now there are say three category, that is three types of skewness. The first one is no skewness, sometimes is also known as symmetricity. The second type is the positive skewness or positive skew, and the third one is the negative skewness or negative skew. So next we have to see in detail one by one each of the types of skewness. So let's start the first types of skewness, that is no skewness. When we have to say that the data consists of, or we have to say that the given data has no skewness. So to understand what is the no skewness, we have to consider say one of the basic example. So let's consider the example. Suppose we have to talk of the height of the student in particular say any of the XYZ college. So suppose we have to consider say XYZ college, and now the strength of that XYZ college is suppose say 1000 students. So right now we have say data of 1000 students, and we have to study the nature of that data. So now see this graph. This graph shows the now the x-axis represents the height of the students in meter, whereas the y-axis represents the height, that is what is the height of particular student. So suppose in XYZ college, so there are say 1000 students, and now is a common fact when we have to talk about say height of the students, and now students is definitely appearing college. So after 12th, so we have to randomly assume say minimum height of the students is say 16, maybe 17 plus. So when the height of the students is 70 plus, that's why we have to start the minimum scope is say 0.9. So minimum height of students in XYZ college is 0.9 meter. And now this distribution shows that there are some very few students in XYZ college whose size is 0.9. Now next we have to consider the scale 1.1. So there are a few more students as compared to the zero point 0.9. So the height of the students 1.1 meter is just like greater than 0.9. In so manner, the height of the student 1.3 is total strength of the height of student 1.3 meter is greater than the previous two. Yeah, we have to say that in XYZ college, the major students has the height 1.5 meter. So it takes just like peak value. And now same thing, there are a few students which are tallest. Same thing, there are very few students whose height is very long. So very few students whose height is say 2.1 meter. So this distribution represents the height of the 1000 students. Now, so from the distribution we have to say that say this middle line, whatever frequency of students that is in this portion. Now the same frequency lies in this right portions. That is the height of the students less than 1.5 meter and the height of the students greater than 1.5 meters are same. Yeah, roughly we have to say that out of 1000 students, say 500 students has the height between 0.9 meter to 1.5 meter. Yeah, we have to say that there are say 500 students whose height between 1.5 meter to 2.1 meter. So this type of frequency distribution is known as no skewness because data are equally lies in both the sides. No skewness sometimes is also known as zero skewness. Yeah, we have to say that this distribution is zero skew. Now also we have to know the word symmetrics. So suppose we have to talk about say these are y-axis, then the distributions that is graph lies on both the side approximately same. So we have to say that is the symmetric curve. So no skewness is sometimes also known as symmetric curve. Yeah, all of you have seen bell. In our school life, we have to see if the period, one period is changed, then there is bell is run. So if we have to see the carefully, the shape of this distribution is just like a bell. These are just like a bell. So sometimes this no skewness is also known as the bell curve. Yeah, is also referred as the normal distributions. Now finally we have to compare or obtain one of the important results regarding this no skewness, that is measure of central tendency. And there are say three parameter of measure of central tendency, say mean, median and mode. So when our frequency distribution has no skewness just like this, so in that case the value of mean is represented by this perpendicular line, and now the same line represents the median as well as mode. So we have to say that when there is no skewness, then the measure of central tendency, that is all parameter mean, median and mode all are same because it is represented by only one single line. Now second we have to study the second type of skewness, that is positive skew. Now again, to understand what is the positive skew, we have to consider one example. So let's suppose we have to talk about the income of an employee in a particular organization, say is a ABC organization. So here in this example we have to talk about say all the employee which are working in ABC organization. So again we have to assume, say in ABC organization, say there are 200 employee are working, and we have to talk about the income of all that 200 employee. So this x-axis represents the income in thousand. Say these are 10,000, 20,000, 30,000 and so on 100,000. So approximately 1 lakh. Now the y-axis represents or it's data of 200 employee in ABC organization. So in today's scenario, we know that a very few person who earn say 10,000. Now there are say more person as compared to this category who earn 20,000. So from this distribution is nothing but is a frequency distribution of 200 employee working in this ABC organization. So from this distribution, it is shown that the major employee lies in this range because it takes the peak value, and now it's approximately the value between 30 to 40. So we have to say that roughly say major employee of ABC organization get the 35,000 salary. Now say there are say very few person as compared to this one who get say 45,000 salary. Again there are say less person who get roughly around 53,000 salary as compared to this, and so on. In this manner we have to say that there are say few employee just like among say 2, 3 or 5 who get 100,000, that is 1 lakh salary per month. So this graph shows the income of an employee, and our aim is we have to study what is the positive skewness. So see here the distribution takes initially as the peak value, then it decreases gradually and attains the concentration, background concentration. So this type of curve is known as positive skew. Yeah, sometimes it is also known as positive skewness. If we have to observe this graph carefully, then you have to see that there is a say right tail in right hand side of these distributions. These are very short. Now see carefully this, these are just like a tail. That's why is also known as right skew, yeah, right tail. Now we have to identify the measure of central tendency when our distribution is a positive skewness. So the distribution takes the peak value at these points. That's why this point is known as the mode. Now this line represents the median, and now if we have to observe, our data lies between 0, these are say 0 and these are 100. So just like 0 and 100, so middle is just like around here. So this line represents the mean value, it approximates. So we have to say that when there are positive skewness, this line represents the mode because at that point the frequency is highest. This line represents the median and this line represents the mean because it divides the distribution roughly in two parts. Finally, we have to see the third type of skewness, that is negative skewness. Yeah, is also known as negative skew. So again, to understand what is negative skewness, let's consider one example. So in this example, we have to talk about the marks of students in a particular statistics test. And now here we have to assume one of the strategy. Yeah, the information is given. The level of statistic exam is very easy. So it's a very easy exam. It's already given or defined in the question. So suppose we have to consider say in a particular class, say there are say 60 students, and these are the distributions of that 60 students. Now x-axis represents the marks of the students, y-axis represents the data, that is score obtained by the 60 students. Now there is a one assumption given in the question, the state exam, that is question paper is very easy, and we know that if question paper is very easy, then maximum students gets the high score. And now as same situation you have to see in the distribution, frequency distributions. So there are very few students who got 10 marks. Same thing, very few students got 20 marks. Similarly, up to 60, there are say few students. Now, there are maximum students say between 80 to 90. So, we have to consider there are say total 60 students. Say around 80% said. So, there are 48 students who gets the score between 80 to 90. So, roughly 85 marks. So, we have to assume 48 students gets the marks between 80 and 90, that is 85. Same thing, very few students got the score 100. So from these frequency distributions we have to say that the nature of the curve is initially just like a stable, or this type of nature is known as the negative skew. Yeah, is also known as negative skewness. Now the as compared to this shape, this position, these are very extended and the tail lies in the left hand side. Now in positive skewness, the tails lies on the right hand side of the graph, so is known as the right skew. Now here the tail lies on the left hand side, so is also known as left skew or left tail. Now again we have to obtain the measure of central tendency, that is there are three parameters, mean, median and mode. So when there are frequency distribution has a negative skewness, so the maximum student gets the marks 85. So measure frequency is here, these are the peak value, and we know that peak value represents the mode. Now this blue line represents the measure of central tendency, that is median. And if we have to talk about this x-axis, so the marks lies between 0 to 100. So approximately the middle value is just like nearest to 50. And we know that mean represents the mid value of the given data. So this line represents the mean, this blue line represents median, and the highest frequency at this point, so this line represents the mode. Now next, when we have to deal with the real life situations, then how we can obtain the, or how we can find out the skewness. Out of these three, which type of skewness is occur? So now there are one of the statistical component which is developed by Carl Pearson. So by using this component Carl Pearson, we have to find out the nature of the skewness. So the Carl Pearson coefficients of skewness is denoted by say S in the case suffix. Now where capital S is stand for the skewness, K for the Carl Pearson, and now is defined as Sk is equivalent to, now is in terms of the measure of central tendency, that is mean minus mode upon standard deviation. So numerator is as it is, and we know that the notation of the standard deviation is the sigma. So the Carl Pearson coefficient Sk is mean minus mode upon sigma. Now remember, the value or the coefficient of skewness is obviously usually lies between the range -1 and 1. The value of Sk is never exceed this interval -1 to 1. Now next we have to see what are the relation between these three parameters, that is mean, median and mode. So Again we have to consider all the three cases. So first case 1, that is no skewness. So as we have to see in this frequency distribution, where there is no skewness, so mean, median, mode all are equal. So here we have to write down when there is no skewness, mean, median, mode all are equal. Case 2, positive skewness. So when there is positive skewness, so mode is appear first, then median, and then mean. See carefully, these are x-axis, and when we have to go x-axis on right hand side, it takes the positive value. So in another word, we have to show that the value of mode is less than median. The value of median is less than mean, because mean is coming on the right hand side of x-axis. So value of mean is the highest. So for positive skewness, first appear is mode, median, mean. So we have to write down for positive skewness, the behavior of the measure of central tendency is mode less than median less than mean. For negative skewness, again these are x-axis. So whatever parameter appear first is less than, that is mean is less than as compared to these two parameter. So mean less than median less than mode. So mean less than median less than mode when there is negative skewness. Now next we have to talk about the behavior of this skewness coefficients. So we have to see that the Pearson coefficient is defined as mean minus mode upon standard deviation. So just for sake of conveniency, we have to write down it here. When no skewness, so mean and mode both are same, and if mean and mode both are same, so numerator takes 0 and the denominator is standard deviation, and we know that the standard deviation is nothing but is a positive square root of variance. So definitely the denominator is always positive, but mean and mode are same, so numerator is 0. So 0 upon some positive non-zero value, so we have to say that the Pearson coefficients Sk is equal to 0 when there is no skewness. No skewness, that is also symmetric distribution. For positive skewness, the mean is greater than mode and mean is minus mode, but mean is greater than, so numerator is positive. So we have to say that the Pearson coefficient is greater than 0 when there are positive skewness. At the last, negative skewness, mode is greater than mean. Now mode is greater than, so overall we have to say that mode is greater than as compared to mean, so numerator is negative. Remember, denominator is always positive because standard deviation is a positive square root of variance, so it's take always positive value. So numerator is negative, denominator is positive, so overall term is negative. So we have to say that Sk is less than 0 when there are negative skewness. So these are the relation of measure of central tendency with Pearson coefficients. So thank you so much for paying your attention.